sir.
Yeah.
I have a doubt regarding Clapeyron equations.
Okay, so this was question, right?
Yes.
So in TS diagram, I'm audible clearly, right?
Yes, sir. Yes, sir.
Okay.
Yes.
So in TS diagram, we know for a given saturation temperature, this is the constant pressure line, right? For a phase change, here liquid, here vapor, and in between liquid plus vapor. Is it correct?
Yes.
So let's suppose this is the for water we are taking. For example, it is 100 degrees Celsius. So what would be this pressure? 1 bar, right?
1 atmosphere.
Uh-huh. So let's suppose now you have changed some pressure or this saturation temperature. Let's suppose this is 120. So for 120, what would be the this pressure? Means saturation pressure. Can you predict that? So how will you predict for that? One equation is there, that is Clapeyron equation. Okay. So for that, and which equation relates with the phase change? Can anyone know? You know, enthalpy dH is equal to du plus
VD.
pdv plus vdp, right? So du plus pdv will become tds, right? Is it correct or not?
Yes, sir.
Yes.
So like this is one equation, and similar this uh, 1 minute. This tds is equal to du plus pdv is there. So if you take du here only, and in terms of du you will write, so then what will happen? Du is equal to tds minus pdv. Is it correct?
Yes, sir.
And similarly dg gives function is there. So for that, anyone know what is the equation? Okay, so it is, I think, vdp minus
Yes.
dt, right? Huh? And for Helmholtz function, it is minus
Internal energy.
dv minus sdt. Is it okay? I think this is correct. Huh? So for the phase change, what is happening? Pressure is constant and temperature is constant. Is it correct or not? Because phase change is two phase system there. Liquid and
Sir,
vapor in between.
which are those last two equations? dg is
This
equal
is
to
dg, and here you df, you can say Helmholtz function. Two equations. One is Gibbs. This is Gibbs free energy G, and F is the Helmholtz function F. So dg is vdp minus sdt. So in the phase change, you know with the Gibbs phase rule. P plus F is equal to C plus 2, right? So if you find the degree of freedom here, so it will become 1. Correct? Is it not? Is it okay to, or not?
Yes, sir.
Yes, sir.
Any doubt is there? Let me know. Huh? So here, if you, what is meaning of degree of freedom 1 here? How 1 will come? Because here phases are 2. Because in between, in phase change, liquid plus vapor would be there. So phases P would be 2. Hmm. And component, because we are taking water here only, so component would be 1. So 2 is already there. What this 2 signifies? Can anyone know?
Pressure and temperature.
Here pressure and temperature is there because two variables are there. So if you apply here for the this mid part, it will F will come 1, right? So what 1 will signifies, because if you here apart from pressure and temperature, if you fix any one, then you can locate that point, means all quantities you can get from there only with 1. So that's why I only told 100 degrees Celsius, you told 1 bar, because here you know condition, if you know 100, then you know what would be the pressure. So this is 1. So in the phase change, pressure is constant, temperature is constant. So pressure, if pressure will become constant here, then it will 0. When temperature will constant, this will 0, means at the phase change gives free energy, change in gives free energy would be 0. Okay, is it correct or not?
Yes,
Hello.
sir.
So now how Clausius Clapeyron equation will come? What is the initially what I told, you know, like dp by dt. What is the meaning of dp by dt? Change in saturation pressure while change in the temperature. Here I given like 100 degree Celsius, you know the saturation pressure 1 bar, and what will be the saturation pressure if the saturation temperature is 120 degree Celsius. So what would be this? So here what is happening? Phase change is happening. If phase change is happening, which equation governs phase change? Gives free energy governs phase change. So what is the gives free energy equation? dg is equal to vdp minus sdt. So for the phase change, dg would be 0. So what will become dp by dt from here?
So
Si.
during presence, why DG would be zero, sir?
Actually, in the phase, while phase changing, here temperature becomes constant, right?
Yes, sir.
Pressure is constant only. So dp would be 0, dt would be 0.
Got it,
Now
sir.
what is the entropy for this part? Like because initially you know the initial condition here. Here enthalpy you do knowing, enthalpy of latent heat. Yeah, even enthalpy of evaporation. This you would be knowing, right? And temperature is constant here only. So you would be knowing the SFG here only, right? What would be the SFG? HFG divided by T saturation into, and this V means of the difference of this and this, means Vg minus Vf, and generally Vg is much higher than Vf, so we usually neglect it. So in this question what it's saying, for water 25 degrees Celsius, dp by dt for saturation, they SS they've given for that. For saturation, dp by dt is 0.189 kilopascal per Kelvin. So this value they have given, correct? And the specific volume for the dry saturated vapor, this Vg they have provided here, and assume the specific volume of the liquid is negligible in comparison to that of vapor, so that you have to neglect there. Using the Clausius Clapeyron equation. What is the Clausius Clapeyron equation? This is the Clausius Clapeyron equation. Okay. So where we are? An estimate of enthalpy of evaporation of water at 25 degrees Celsius. So this you know, T. T, what is the T? 25 is given, so 298 is the T. So T you put as 298, Vg is given, and this is given. So easily you can find the HFG. Is it so or not?
Yes, sir.
So I'm not solving it. I have given complete detail whatever is required there. So it hope someone has sent this question, so I solved it. Okay.
Okay, thank you, sir.
So fine. So for today we are starting 1 minute.
सर स्पेसिफिक वॉल्यूम 43 थोड़ा ज्यादा नहीं हो गया ये?
Whatever they have given, you have to put that.
43.38 मीटर क्यूब.
It is much big. Okay, fine. So you put that. Whatever answer is come, that is the answer. It is get previous year problem, I think. So what? So what is there?
Yes, sir. 2016.
Okay. So we are starting with the that psychrometry and the air conditioning. So first thing, what is the air conditioning? Quick words in 1 minute. Can anyone tell?
Modifying the conditions of air for our comfort.
Means okay. According to our comfort, we want to change the condition of air, right? So
Yes.
Yes.
like in air conditioning, nothing. We are controlling the property of air. So what are those properties? That is my main aim. Can anyone tell?
Humidity.
Okay.
Relative humidity and temperature.
Humidity and
Humidity.
Temperature.
temperature and velocity. Velocity also, because if wind would be flowing at high velocity, then it would be also be difficult. Huh? So and also one last thing is purity. Purity means oxygen content. If oxygen content would be less in your air conditioning air, then it would also be difficult to survive there. Okay. So controlling of property of air, omega T, velocity and purity. And what is psychrometry then?
Study of those properties.
Like how you are going to control and that also, and about them. It is like you can say it is branch of science where we are going to study those things. So in air, two components are there. Like moist air first we'll take. So what are two components?
Dry air and moisture.
Moisture.
Dry air and water vapor directly we'll say. Huh? So like okay, that here I have written in water vapor. Okay, 1 minute. Okay, dry air will take. Dry air. What is the nitrogen content and what is the oxygen content?
78 or 79.
By volume, first tell.
By volume, 21% oxygen.
By mass, both I will write. Okay. So first we will write by volume. It is 79% nitrogen and 21 approximate. We can say this.
21.
Here what? 77 this and 23 this. It's just for general. Okay. Now coming to okay, this is for just a basic introduction. Now we will quickly see the psychrometric properties here. So first one is the specific humidity or absolute humidity or humidity ratio. Can anyone tell just a definition what is this? If no, humidity is what? When you are saying like today is very humid, what that means?
Less water molecule in the air.
Okay, any other person?
Mass of water vapor to total mass.
Which total mass?
Air.
Air only or a total mass?
Sir, dry air. मतलब कि the mass of moisture per unit dry air mass.
Okay, so like space, these three terms keep in mind. Otherwise, some questions you will commit mistake. Okay, these three, any word they can use: specific humidity, or absolute humidity, or humidity ratio. Okay, so it is the ratio of the water vapor to the mass mass of the dry air. So what would be the unit of that?
कुछ नहीं. kg by kg.
No.
Unitless.
Kilogram of some water vapor per kg of dry air. Okay. Actually, dimensions you will take, then nothing will come. But unit you have to take like 19 grams of water vapor per kg of dry air. Okay, getting or not getting?
Yes, sir.
Yes, sir.
So okay, this would be let's suppose this is our sample control volume, and here we are taking PT. What is PT? Total pressure. Okay, V is the volume, T is the temperature, and MV is the mass of vapors there, and MA is the mass of dry air. Okay, so here we will write PV is equal to MRT. Is it fine?
Mhm.
And same for this dry air will write. Okay, now divide both equations, then what will come? PV by PA equal to MV by MA, and a TT will get cancelled out, and here will come RV by RA. So now PV by PA, sorry, PV by PA, MV by MA is what?
Specific humidity.
This is, and this we can convert. This is characteristic gas constants that we convert to universal one and divide by molecular weight of that. Vapor molecular weight would be 18, and similarly this will write here R bar, and air molecular weight usually we take as 29. Okay, so we'll take 29, so this will get cancelled out, so omega will become 0 point, sorry,
622.
0.6. You have to remember this. If anytime you forget, then quickly you can come here. So PV by, what is PA?
Pressure in air,
Pressure of
atmospheric pressure.
only dry air. So what is PT is PV plus PA. So here you can take PA as PT my PT. I am not going to write PT every time, but here I will write. Otherwise, P minus PA will write. Okay, PT minus PV. This is the formula for specific uh, humidity. So here generally, what is the PV? How will you get? Okay, that generally is given in the
Corresponding to saturation temperature.
saturation temperature of the water vapor. So if you know that, and PT would be given like pressure of the air is this much, so that would be considered as PT. So easily you can get this. Hmm. So remember this formula, because without starting it, no problem will start. Okay, so specific humidity is 0.622 PV by PT minus PV. Sorry, PV by PT minus PV. So now one more thing, relationship between omega, MT and MA. What is MT? MT is the total mass, MV plus MA, and omega is our this specific humidity, and MA is our dry air mass. Can anyone know? Do anyone know what is the relation between them? Those MT is MV plus MA. Is it correct?
Yes, sir.
So we know MV by MA is omega. So we will try to divide by MA. So it will become MT by MA. It will become MV by MA. So it will become omega. Is it correct? It will become 1. So we can write MA is equal to MT by 1 plus omega. So this also we can use somewhere. So these two formula you just simply write, and then we'll proceed further. Should I go forward?
1 minute.
Okay, question will do later only. Now will not do. When you complete, let me know. I will go forward. Okay.
Okay, sir. Done, sir.
Okay. Okay. So, what is relative humidity? Anyone?
Mass of water vapor by mass of water vapor when the air is saturated.
Okay. So, relative humidity is denoted by phi. It is the mass of water vapor present in the our air to the what maximum amount of water vapor can be present in the air. Okay. So, okay, fine. So, this would be the again will come. So, what would be the formula for that? Like we know, PVV is equal to MV RVT, and similarly we can write for our saturation PVS into V is equal to MVS RV into T. So when divide both equations, so MV divided by MVS becomes PV divided by PVS. This will become 5. So as of now, might not be you are able to relate much, but when we are solving question now, that time I will show how to find in numericals that those things. Okay. So now write this formula. Now physical significance of relative humidity will see. After before that, I will also tell one more thing like degree of saturation. Or percentage humidity. So actually this nomenclature is more important. Okay. So you need not to, things are easy, but if you mix up the names, then it might be difficult. So it is denoted by mu. So can anyone know what is this? If not know, then simply say don't know. I will tell.
Done.
Degree of here, what is this relative humidity? It is the simply the ratio of mass at the our normal condition and to the mass in the mass of water vapor in the saturated condition. So here it is the ratio of the specific humidity at the normal our dry bulb temperature to the specific humidity at the saturation temperature. Okay. So but just now I will show like both relative humidity and this is same. So when we'll open this formula, because we know the formula of specific humidity, right?
Yes, sir.
So if you know the formula for them, then 0.622 will cancel out from each numerator and denominator. So that I'm not going to write. So directly I will write PV divided by here PS will come. Yeah, PS write or PVS we can also write because here nomenclature that I have given. And here will come PT minus PV, and here will become PT minus PVS. Is it correct to everyone?
Yes.
So after that what will become? It will become 5, this first term. And PT is like in kilopascals. If you convert to, this is usually 1 bar, 1.01 bar our atmospheric condition. And this PV, anyone knows what is the value of approximate value of PV, PVS means water vapor pressure? It is generally 2 to 4 bars, like sorry, 2 to 4 kilopascals. Okay. And PT is like 101.2325 atmospheric pressure. So 2 is very much less than the this value, and when it will subtract, it will very much close to this term. Approximately it comes as 1. Okay. So degree of saturation will show similar things as the relative humidity. Is it okay?
Yes, sir.
Yes, sir.
So just simply for your knowledge, you have to know this. Otherwise, mostly your work will be done with relative humidity. So what is dry bulb temperature? Quickly, can anyone tell?
So dry bulb temperature.
Using the ordinary thermometer.
Okay. So mm, here like a relative humidity, if one, then what it means? Our air is completely saturated. Whatever amount of water vapor it can maximum take, that is already there. Okay. So one is meaning that it this if condition is this, then we will say saturated air. If directly written saturated air means relative humidity is 1 is given, and if a unsaturated air, then 5 would be less than 1 always for unsaturated. So dry bulb temperature is nothing. Dry bulb temperature is the normal our air temperature. Okay, normally air temperature. So in questions, nothing, nowhere it will say like a temperature of air is this much. So it will simply say dry bulb temperature of air is this. So you have to think, okay, dry bulb temperature means normal temperature of air is this. And now what is wet bulb temperature then?
Temperature measured by passing the air at some velocity of
Next, from where velocity means not getting your thing, what you saying?
Temperature measured by using wet bulb or wet cloth.
So what happens with temperature measuring with wet cloth?
So
Air would be passing through the that wet cloth, and that would be measured by the thermometer.
So okay,
wet
that's
cloth,
fine. Actually, what happens when it is happening? That I am saying.
water evaporates, and while it's evaporating, it takes latent heat from thermometer, and that's why temperature reduces.
Okay. Okay, so definition is fine. So like it is just steady state, like one apparatus is there. There we used to measure our dBT and WBT. Okay, dBT and WBT measured in. Anyone know device name? Sling psychrometer. Okay. Psychrometer. So like here is nothing. Two thermometers would be there. Like one thermometer, and here first thermometer some cloth is put here, and in second thermometer here. Sorry, this is the first and this is the second. So here simple thermometer is there. No cloth. Here cloth would be there. Cloth is wrapped on the tip, and air will come here, like touching it. I means it will touch here, and air will flow. So some reading it will take, some reading it will take. Whatever this thermometer will take, that is our dry bulb temperature, and whatever this will take, like suppose it's 30, it would be here. So actually, what happens? Uh, this cloth similar like one person has told, it will absorb water is here, liquid water. So this temperature is more than the saturation temperature. That with TS diagram, if you will see, then it would be better. After dew point temperature, I will show all three in one, so that would be better. So that would be more clear, that point. So and also wet bulb significance of wet bulb temperature, can anyone tell? Okay, one thing is like our cooler we have using in our house, right? Hello.
Yes, sir.
So
Yes, sir.
cooler or desert cooler we also say. So that the term desert cooler, why desert came first, that also would be clear here. So what is the working of cooler? It some hot air in our summer season it will come, and we used to put water in our tank there downside, and we used to get cold air. Okay, let's suppose here our exhaust, this is there, fan is there. So here we used to put nets, right? All three sides. So here what happens? Some motor is there, so water is running all through sides. Okay. So when this exhaust is running, and hot air from outside will come to here, and it will go. So when this air max, let's suppose its relative humidity will combine all these things here. Okay, listen clearly. So this might be useful later also. So let's suppose phi is, think of like you are in the Rajasthan. Okay, here very hot season is there, and relative humidity is usually very less. Why relative humidity is less, I am saying? Because there we know water is very less in surrounding also. So in air water would be less, so phi would be less. Water less means currently in the air is very less amount of water vapors are there, but maximum possible is very high. So this is less and this is high, so phi would be like 0.1 0.2 this much. Okay, 0.1 or 0.2 if so what is the tendency of this air? This air is condition is this. So this has tendency, it can absorb lot of amount of water in it. Are you able to get or not?
Yes.
Yes, sir.
So a tendency of this air would be like it can absorb lot of amount of water vapors. So here liquid is there, liquid water, because running due to the whatever inside motor is there, due to that water is there. So when this air comes in contact with that water, so liquid is there, liquid water. So liquid droplets will convert to the when convert to the vapor. When liquid convert to vapor, what happens? It requires latent heat,
Energy.
right? HFG. So from where that latent heat will come? From air, because initially let's suppose air in Rajasthan temperature is 40 degrees Celsius, and this water is there, that is somewhat cold water. So this and this our air is able to get absorb more air, because its relative humidity is very less. So it's a tendency to absorb more air, but how it will absorb? But here liquids first convert to vapor, then only it can absorb. So it will convert to liquid to vapor, but for that this much amount of energy is needed, and this much amount of energy would be given by this air. Initially its temperature is 40 degrees Celsius. Let's suppose it will drop its temperature to 25 degrees Celsius. Then we will get this 15 degrees Celsius, right? 15 degrees Celsius drop is there, but Cp delta T, Cp into delta T of air, that would be there, and Cp is of the air. Okay, so this would become our latent heat, HFG. So it will like totally it is cycle. Our requirement whenever this will become our saturation, phi will become 1. At that after that our air is have no tendency to suck the more air. So that time no cooling would happen. Whatever temperature would be there, nothing, no advantage of cooler is there. And that also here it might get this HFG also. If anything is not there, like its temperature, whatever temperature of air is there, but it cannot go below that, so HFG would not be there. And if we go to coastal area, there high relative humidity would be close to 1 or 1, there air has no tendency to absorb more water vapor, so our this cooler will not work. Have you able to got what I told at this much time?
Yes, sir.
So what is wet bulb temperature here then? Question again came then. So temperature, now again listen. Here 40 degrees Celsius, let's suppose air came and it absorb water vapor from here, and that liquid convert to vapor, and that in order to convert that liquid to vapor we have to give more some amount of energy of latent heat that would be given by the water vapor, sorry, air, that would be given by air, and due to that a temperature, due to transfer of that energy, temperature of our dry air will decreases. So that decrement like from 40 to it will come 25, and its relative humidity become 1 because maximum amount it will try to change. So when this temperature drops there, so what would be the final temperature? That is our dry bulb
25
temperature.
degree. 25 degree.
That would be our wet bulb temperature.
Wet bulb. Yes, sir.
Have you got it now?
Yes, sir. Yes, sir.
Same thing happens in our, in like a village area. We used to use the earthen pot like in summer season, right?
Yes, sir. Yes, sir. Got it. Like due to that reason, the water is bit chilled in comparison to the normal water.
So same working is there also. Okay. So so first significance is like whatever minimum temperature we are going to get in our this desert cooler is the wet bulb temperature. Whatever the temperature of the water in the earthen pot in summer, minimum temperature possible is the wet bulb temperature. Is it clear?
Yes, sir.
And again, last one is like for our syllabus you would have studied the cooling tower, right?
Yes, sir.
There also same thing happens. There in cooling tower, maximum cooling is possible till wet bulb temperature of air only. Okay.
In thermal power plant, we
There.
use.
That will come more detail in power plant, but for example only you have to tell what is the significance of wet bulb temperature. So these three examples you have to know. Okay. So should I go forward?
Okay, sir. Yes, sir.
If any doubt is there, clearly ask now. Otherwise, later it will become problem when we are using our psychrometry chart there. That point of time, finding the wet bulb constant lines and those concept is clear, then you can easily get. If not clear, then you would be stuck. Okay. So should I go forward?
So in that
Yeah.
PVR, what is the PVR?
Here.
There is an equation right in the left corner, MV by MV. There is a subscript R.
Left corner, which like top left or top right? This way you can tell.
That is MV by MVR. MVR is the R that subscript.
Here, this one you are saying.
MV by MVR equal to PV by PVR equal to 5. Relative humidity. That box.
This.
Yes, sir. That small r is that a subscript or anything?
No, R is not there. This is MVS. Mass of water vapor at the saturated state. Okay.
Okay, sir. Saturated state. Okay.
I'm going forward. Okay. If any doubt is there, you can ask me. So one more term is there. Wet bulb depression. WBD. So it is simple nothing. WBD is DBT minus WBT. Okay. So if phi is equal to 1, then what would be the 1 minute? Phi is equal to 1, then what would be the WBD? Can anyone tell quickly?
Zero.
It will become 0 because no temperature change would be there because air has no capacity to take more amount of water and its temperature will not reduce. Okay. Is it clear or not? If anyone has not clarity like how it will become 0, then I will explain. If it is clear, then I will go forward.
Sir, uh, yes, sir. One second, could you please repeat why it would be zero?
Okay, phi 1 means what? Air has no capacity and no tendency to accept more amount of water vapor inside it, right?
Yes, sir.
If it has no tendency to take any water vapor, then when air will come here, then whatever amount of water here is there, air will take no air.
Zero.
So no drop in
Okay,
temperature.
got.
No drop in
Yes, sir.
temperature
Yes, sir.
means
Got.
this would be
The
decrease in
temperature
zero.
increasing would be zero.
So similarly, if phi would be less than 1, then what would be the WBD?
Then temperature might.
It will change. It will change, but more
Yes.
than 0, right?
Yes, sir.
Then will come like less than 0, more than 0, equal to 0. That is
Mhm.
okay.
Yes.
Now coming to the dew point temperature. What is dew point temperature? Can anyone quickly tell?
Temperature at which dew will form.
How dew will form?
So due to saturation of the water vapor, when air gets cooled in comparison to the normal temperature, uh,
1 minute. Some person has told like when dew will form. It is the this like dew point temperature. Okay. Let's suppose uh, this is our initial condition of air. Okay, fine. 1 minute. This is our initial temperature. So now we'll cool it. Here also dew will form, right?
yes, sir.
So is it dew point temperature?
No, it won't be.
Sir, but cooling is along that inclined line where pressure constant.
You have to tell cooling along the constant pressure line when dew will form, that is the dew point temperature.
Okay, sir.
Because here temperature keep on changing everywhere, na? Getting or not?
Yes.
Temperature will change, but
Yes,
along
got
a
it.
constant pressure line. Page constant.
Got it.
So what is exact definition of dew point temperature? If we cool our air at a constant pressure, when dew will form at that temperature is the dew point temperature. In other words, saturation temperature of our corresponding what vapor pressure. Is it clear?
Yes.
What is this pressure? This is vapor pressure line, right?
Yes, sir.
So saturation temperature along the our corresponding saturation temperature of the saturated vapor, that is the dew point temperature. Is it clear?
Sir, that please repeat that last lines.
Like dew point temperature, first you have to tell like if we that you can easily say if we cool at a constant pressure from a given dry bulb temperature, at constant pressure if we cool, and at which point dew will start to form, that temperature is known as dew point temperature. In another, if like in one word you have to tell saturation temperature of the our water vapor pressure. Saturation temperature of our water vapor pressure is the dew point temperature. Okay.
Okay.
Some saturation temperature would be there for this pressure, na? This is the saturation temperature. So in one word you can tell T saturation would be the dew point temperature. So now one more thing. Now I want to show all three temperatures. Three temperatures you have studied, right? Dry bulb temperature, wet bulb temperature, and dew point temperature. So all three now we want to see in the in one place. So that would be more clear to you. Let's suppose this is our initial point. So what is the dry bulb temperature? This is our dry bulb temperature, is it right? And what is dew point temperature? This is our dew point temperature. Fine. Okay, 1 minute. Can anyone tell what would be the this pressure? Sorry. Let's suppose this is going this way. So what is this pressure? Let's suppose this is PV. So what would be this pressure? Can anyone tell?
Yes, atmospheric.
What?
Atmospheric pressure.
Why atmospheric pressure would be this? This is the saturation pressure of water, right? Means
when relative humidity 1.
at this pressure, because here at this temperature, whatever temperature of your dry bulb temperature, at this point, this would be the relative humidity 5 would be 1 here, and your means actually it never happens like what I told here. In here what I told you, 5 will become 1, but generally ideal condition will never be met. So 5 will never become 1, because if 5 will become 1, then you will not feel cool, because same thing happens when cold air will come from you here, and here you are there. So how you feel cooling? Same thing will also happen from here also now, because you would be sweating, and this will take from you. So one thing will happen here, and same process will when air will be coming here, you will also feel cool by same mechanism. So
Sir, sorry for interrupting. Sir, why if 5 would be 1, then why won't we feel cool?
if
Because
5
the
would be 1 here,
temperature.
after coming out of here, then why will you feel cool? Because some sweating should be evaporated from you na, then only you will feel cool.
Because due to that latent heat.
That will take from out of your body, and then you will feel somewhat comfortable. So same
Yes,
thing,
sir.
if it will here it would be said that way, like a relative humidity coming out of like 0.8 0.9. So if it would be 1, then this would become what? Wet bulb temperature, but generally it is not so. So where wet bulb temperature would be here? Can anyone tell, if you have got correctly last discussion?
Between the two temperatures.
Somewhere in between, because now I told coming out of that, generally wet bulb temperature would be somewhere in between. So let's suppose 5 would be 0.8 0.9, that you can't know, but after getting the wet bulb temperature you can easily find 5. So let's suppose this temperature, okay? So in between anywhere it might be, right? Is it okay?
Yes.
So here you have also seen like vapor pressure increased while wet bulb temperature. Is it so? Have you able to see that? Because here it is the PV of WBT.
What, sir?
Vapor pressure has been increased when we are looking for the wet bulb temperature. What does it mean? It means
Air has
air
got
has absorbed
moisture.
the more molecules of water vapor, so its pressure got
Water.
increased. What would be that pressure? This would be that pressure. Is it okay?
Yes.
So now you can write one more thing, like if phi is less than, sorry, first I will write for, okay, phi is less than 1, then what will be the order of the temperatures there? dBt, dBt would be highest, right? Then WBT, and then dPt. Is it correct?
Yes, sir.
Yes, sir.
I would be 1, then
All are equal.
all are equal, okay? dBt, WBT, and dPt. Till now everything is fine, right?
Yes, sir.
Okay. So actually we can solve lot of question in that, but we'll solve all questions one time, okay? So currently we are completing theory quickly, and then we'll do solve problem. Is it fine?
Question, sir.
Huh.
In case of PV, when we are going to cool, then it will travel along inclined line towards saturated that curve, and in case and towards wbt, how it will go that point pv.
What you said? Okay, once again, can you speak?
In
You
a
are saying
second,
for people, let me, wherever I'm not
that
coming to
point.
you, that let me know. For PV, you told like if you cool, this will become this, right?
Yes sir.
And
Then we will go to
now this temperature will become what? Dew
now
point
means
temperature. Okay.
yes.
Now what is your question?
Now means if we are going to cool by that desert cooler mechanism, then how that WV, WVT will
That
means.
is a complex process actually. Huh? So there, what we used to think that we'll see later, like in psychrometry chart, WBT lines, how we are going to get. Okay, we usually think uh, it is the isenthalpic process. Okay, here what happened? 1 minute. Here, um, it's generally nothing but it is the exchange of energy, right?
Yes.
Here, like some energy of the air has been given to this water, and the water has become vapor and came into the air, right?
Yes.
So enthalpy of total final enthalpy of air initially and finally would be close to same. Is it fine or not?
It's total enthalpy.
Total enthalpy. Is it fine?
Yes.
So and final temperature is also same. Is it so?
No sir, final temperature is reduced.
Final temperature is reducing, right? So
Hmm.
one thing what we can say, actually there and here one thing you got, like h would be the constant, right? H total.
Yes sir.
So in any curve we used to, like in a psychrometry, constant enthalpy line used to be there. Okay, hello.
Okay sir.
So we used to follow that line, like for that constant enthalpy line will follow, and we know we usually know the initial condition there, like our condition, initial condition of air is this, and final condition of air is this, like temperature we would be knowing, or relative humidity, final two things we would be knowing, then we can fix our point. Okay, this is our final point. So till that point we constant enthalpy line we will go. Have you got what I told?
Yes sir. By moving along constant enthalpy, we will get the condition.
For WBT, you have to think like it is constant enthalpy. Generally, very
Okay,
little bit change is there, but usually with physics also it is clear, like okay, constant enthalpy line would be there.
okay sir. Yes.
Okay. Okay. Now last thing is there. After that, I will be solving some problems, and remaining thing we'll see. One is enthalpy of moist air. So our enthalpy of the total moist air would be the sum of the our dry air and the enthalpy of the our water vapor. So here first we'll find the enthalpy of our dry air, and separately of this water vapor, and then we'll simply add. If you directly mark up the formula, then might forget. So quickly I will derive it, and that you can remember easily. So for dry air we know DHA is equal to MACPA dt, right? So here what we are assumption we are taking, like HA is 0 at 0 degree Celsius. Okay. So at T degree Celsius, what will become? HA will become MACPA into T. And what is T here? Here we have taken degree Celsius. Okay. So T would be in the degree Celsius. That keep in mind. In all thermal subjects, wherever we are using small t, it is in degree Celsius. So it is for the dry air. Now coming to the water vapor. So here one assumption we usually take. Let's suppose this is TS curve, and this is the 0 degree Celsius. Okay, so for 0 degree Celsius, here enthalpy we are taking as 0. Okay, HF we are considering as 0, and this HFG we are taking as 2500. So that I will write here. HF we are taking, assumption is there, so that's why you have to remember. HF 0, HFG is 2500 at 0 degree Celsius. Okay, 2500 kilojoule per kg. Okay, that is there. And after that, if like heating is there, so that Cp of vapor, that would be 1.88. It is for the water vapor. Okay, this keep in mind, it is for this. So now easily we can write like HV. HA we already have. HV if we know, then total H we can find. What will be the HV now? Let's suppose mass of our water vapor is mv, and we started from here, and now it will take latent heat, because our water vapor usually here, right? So such superheated region. Is it clear?
Yes, sir.
So latent heat would be there, because HF we have taken here as 0. So latent heat it will take. After that, this sensible cooling at the vapor stage would be there. Latent heat plus Cp of vapor into T. So T would be our dry bulb temperature. Here also dry bulb temperature. Cp we know for air 1.005, mass you will be calculating. So that I will tell again. MV latent heat, now you know 25 we have written, 2500 plus 1.88 into T. So now this is HV. So now if we add both of them, H will become HA plus HV. So when you will add and divide by MA, that you will see H by MA, it will become, here MA will gone, so it will become Cp of air into T plus, now for HV it will become MV by MA. What is MV by MA?
Omega, sir.
It will become omega 2500 plus 1.88 T. So this will become our final formula. So H by MA we can also write as small h. So what would be a unit of this? Kilojoule of MA we have divided, so per kg of dry air. That is important to write. Is it fine?
Yes, sir.
One formula initially I told you where that would be useful, because for this sometimes total mass would be given, but MA would not be given. So this formula, this MA, total mass you can take, divide by 1 plus omega, just find specific humidity, and MT by 1 plus omega. When you do, MA will come. Have you got it where we have to use this?
Yes, sir.
Keep these things in mind, otherwise and while solving the problems these all things will be needed. That's why I am telling one by one. So should I go forward?
Sir, in this last box at end, so equal to small h, what was that?
Like in this, H by MA is equal to CPA into T plus omega 2500 plus 1.88 T equal to, we usually H by MA we write as small h.
Okay.
So any doubt more?
No, sir.
Okay, so should I go forward now?
Yes, sir.
Okay, so okay, now I will like just start the how psychrometry chart is made. So after that we'll solve few problems, and then in next class we'll see remaining theory part, and after that I will solve problem. So one thing you might be knowing here, like TS diagram. Hmm. Let's suppose this point is A, and here B, here this point is C, this is D. Whatever I am telling, that you are able to get or not, that tell me first. Hello?
Yes, sir.
Whatever I am telling, are you able to get or not?
Yes, sir.
Fine. This temperature, let's suppose this is pressure P1 and this is pressure P2. Saturation temperature corresponding to pressure P1 is T, and the saturation temperature corresponding to pressure P2 is the T dash. Okay. And here we already know, here liquid used to be there, and here vapor used to be there, and in between liquid plus vapor would be there. No doubt till here, right?
Yes, sir.
So after that, this is the TS diagram. Now same thing I want to draw in the PT diagram. So here like two phase region would be like a dome in TS, PV, all curves. In PT, two phase region is like what? How it will be showing in PT? Anyone knows?
Absent. It is absent. Two two phase region absent in PT.
How would we like that?
Straight line, or sorry, line.
One simple line, right? This way. Is it clear to all? Hello.
Yes, sir.
So this corresponding to this P and T, let's suppose first point is this, okay, and second point is somewhere here. This is liquid and this is vapor, and here liquid plus vapor. So this point, only one point here, it would be like A, B, C. All three would be here. Is it correct? Hello.
Yes, sir.
All A, B, C would be here, right?
Yes, sir.
And D, E, F would be here. So this P is what? Like PV. This is vapor pressure, right? In the our psychrometry. Hmm?
Yes, sir.
Hello.
What, sir?
This P is vapor pressure, right? Different pressures.
Yes, sir.
So in this PT, this would be vapor pressure, and there is nothing. We just simply one thing. We want to change the axis only. Curve is same this way, and now curve would be like that only. And now we want to change, just a flip. Sorry, just this way. Pressure will write here only, here, and the temperature here. Is it okay?
Yes, sir.
So that curve should be mirror image.
No, nothing. Curve is same. But just we have changed the axis. PV here it is, now we have taken here only. That's fine. And
Okay, so in first case, temperature was going to increase in right side, and in second case, it will decrease.
no, same temperature is here only, this way. Temperature will increase here, here it will decrease. Okay.
Okay,
Temperature will increase here, but like here 35, here 30. Is it fine?
yes, means, and we are analyzing from another coordinate.
Ah, just higher temperature would be here and lower this side. Just we have changed it. Here it would be a liquid and here vapor. Sorry, here vapor and here liquid. That's we change just because our water would be there in the vapor form mostly, right? Hello.
Yes,
Where
sir.
where vapor?
In air, what is the phase of water there? Vapor only, na? So we are more interested in the vapor area. Here we are not interested. Here liquid is there, na? So able to get or not?
Yes.
So we are interested in this part. So that's why we have changed the axis such way. So one thing, this is PV. So what is omega? 0.622 PV divided by,
PT minus PV.
if you know PV, and for our atmosphere PT is fixed 1.01325 bar. It is fixed. If you know PV, then easily you can find the omega. Is it so?
Yes, sir.
So means from here what you can say, omega is function of PV. Correct?
Yes, sir.
So either PV we can write, or simply we can write omega here, or not.
Yes, sir.
Now this temperature is dry bulb temperature, and this omega, you know, omega initial condition, if you know PV you can find omega, right?
Yes, sir.
So now you know two things for air. If you know omega, and if you know T directly, if you know like temperature 28 degrees Celsius, just draw one line this way. And if you know omega is some value, so draw this line this way. So whatever this is there, this is our condition, initial condition of air. So we can get all properties from here. Properties would be there, that we'll see later what properties we can get. So till now any doubt is there? Hello.
Yes, sir.
It is like happening too much, then we'll stop here only. We'll solve one or two simple problems, and later we'll also see. If it is fine, then we can carry forward.
Okay, sir.
So okay, so
So you can give us some examples or numerical or something, one question or two.
questions we are doing now after that. Actually, I'm thinking like we'll finish like all types of lines in this chart. Later we'll solve problem, but I think it is too much for today. So we'll solve some problems now. Okay.
Okay, sir.
Hmm. Okay. See the first problem first. Here is a stream of the moist air, m dot is given. M dot means total mass. Okay. With the humidity ratio of something, some kg of dry air mixes with the second stream of superheated water vapor flowing this. Assuming proper and uniform mixing with no condensation, the humidity ratio of final stream. Okay. 1 minute you take and let me know the answer. Anyone trying or should I?
Yeah, sir. 0.02.
Okay, some other person getting same. What is omega? Mass of water vapor upon the mass of total air. Sorry, mass of dry air. So here it is given as
0.01.
humidity ratio is given as 0.01. So like from here you can find the mass of vapor.
Moist air.
Mass of moisture. Sorry, how much it is coming?
The mass of moisture is given.
10 kgs.
It will become 10 kg, right? You can get it from that formula also. Ma is equal to mt by 1 plus omega, right? From there we can get, right?
Sir, here mass of moist air is given.
Yes, sir.
No, sir, no, I used that formula. Means it is not a formula. Mass of moist air will be equal to mass of dry air plus mass of water vapor.
Same from that way
So
also
we have,
it has come, no, only. That also you can use. Like total mass would be the mass of air plus mass of vapor, and
mass of moist air is given.
this
So we
total would.
can you means convert
Yes.
all of them in one variable.
Hmm. Like here you can convert mv as omega ma, and this ma will become common and it will become 1 plus omega, right? This way, right? Hello.
Yeah, sir.
So from here ma will become 10, right?
Yeah.
So mv will become zero point 0.1 from here, and here we are seeing like initial mass of vapor in our stream of air is zero point 0.1 kg per kg of dry air. So this is the first stream. Second stream of the superheated water vapor flowing at this zero point 0.1 kg per second. It will come zero point 0.1 initially is there. Again zero point 0.1 is coming and mixing here. So assume proper and uniform mixing with no condensation. Humidity ratio of the final stream is. So now final what is the mass of total water vapor? Zero point 0.2, and dry air is only 10. So it will become 0.02 kg of per kg of dry air. So can you solve this question quickly? If the volume of moist
100%.
100%, okay, anyone getting the same? The volume of moist air with 50% of relative humidity means this is there. So let's suppose this is phi is 0.5 here, and some pressure is there, PV. So isothermally reduced. Let's suppose this is our initial temperature, T. Isothermally reduced to half of initial original what is it? Isothermally reduced. Isothermally means temperature would be the same to the half of its original volume. Means if initial volume is V and the final volume is the final volume would be the V by 2. If volume decreases and isothermally is there, then we know pressure is directly proportional to the volume. Is it correct?
For
Hello.
isothermal, it is inversely.
So
Oh,
inversely,
sorry,
sir.
sorry, 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 sorry. Inversely proportional. So if like volume would be the half, then pressure will become 2 times. Is it correct?
Yeah, sir.
So let's suppose this is PV1, then PV2 would be the 2 times of PV1. Correct? So here relative humidity is what? Phi is equal to PV1 by PVS. And now it's a pressure, this is phi 1, and phi 1 is given as 0.5, and phi 2 we have to find. There we know the PV2, but PVS will be same. Is it correct, right? PVS will be same for both cases, because we are not adding any other amount of water there and nothing. So PV and because this temperature is also the same. Isothermally we have did, that's why it is same. So PV2 is already there 2 times of PV1, and PV1 by PVS is already from this equation is 0.5. So 2 into 0.5 is 1. So relative humidity is 1. So in a percentage we can write as 100%. So if any doubt is there in this problem, I can tell again. If any doubt is there, I will tell. If it is clear, then we'll go forward.
Sir, how PVS is same in both cases?
Generally, how we used to find the PVS? Like in some problem I recently told.
It is fixed for given condition of air.
For a given temperature it is fixed. Let's suppose this is our temperature, and we have given keep on giving water here, and this temperature will come, huh? So this we said here na, this is PVS our, here phi is 1, huh? Because at the given temperature, when relative humidity will become 1, at the same given temperature we keep on giving water, we'll give more water, and when maximum amount of water would be there, then its vapor pressure will increase, and it will come to this place. Means, sorry, so we have to come here, this temperature, and at this temperature when we'll come to this stage, and whatever would be the pressure here, that would be the our saturation pressure at that given dry bulb temperature. Is it clear?
Yes.
Here what we are doing, here isothermally we are press given, right? So isothermally we have reduced the volume, so temperature is not changing anywhere, right?
So for a fixed temperature, fixed PVS.
Yeah. If a dry bulb temperature, P like PVS is function of only dBT. If you know dBT, then whatever would be the saturation pressure for that temperature is the PVS. What is PVS? PVS is nothing the saturation pressure at that temperature, at dry bulb temperature means. Getting?
Yes, sir.
Hmm. So if it is isothermally, then it would be same for both cases. Fine. Is it fine or not?
Yes, sir.
Okay, we'll solve this crop problem and then we'll stop for today. Just try to solve it, whatever we have got this time. First problem first do quickly, and second will do. Second I will do.
Sir, P saturation 2 times.
Where? Hmm. The second one would be used in the second problem. Okay. It has written now. Oh, it is, I forgot to write here at 150 degrees Celsius. So first one would be used in the first problem and second one would be used in the second. So okay, you try for 2 minutes, then we'll start.
Sir, specific humidity coming 0.023
Okay,
kg per kg of the air.
0.023. Next 5 8, right?
Yes,
Yeah,
sir.
sir, I am also getting the same.
Kg of kg dry air. Okay, so we'll solve this quickly. Like here, first given relative humidity and the moist air at the dry bulb temperature of the 40 degrees Celsius. Relative humidity 50%. Total atmospheric pressure is 1.01 bar. R of H2O is this, and saturation pressure is this. So, what is the relative humidity? PV by PVS at a given dry bulb temperature. Dry bulb temperature is 40 degrees Celsius, and here saturation pressure is this, and phi is given as zero point 0.4. Sorry, 0.5. So 0.5 PV by 7.38. What is coming here from PV coming here from here? What is the value of PV?
3.69.
So from here you got the PV and easily can find the omega. Omega formula is what? 0.622 PV by PT minus PV. So 0.622 PV is 3.69 and PT is 101. You have converted this to the kilopascal only, minus 3.69, and when you will solve it, it will become 0.02358, right? Solve the second one. Actually, second one is the important. So here
Sir, in
what?
first one,
Huh?
there is no role of RS2O given.
No, I don't think it is needed here.
Okay.
Mhm. So in second problem, if the moist air is compressed to 5.05 bar, means initially it is the 1.01 bar. Now it compressed to 5.05 bar. Corresponding dBT is the 150 degree Celsius. Relative humidity they asked. What is the relative humidity? PV by PVS. So PVS for the 150 degree Celsius, you know, correct? Hello, hello, hello. Am I audible?
Yes, sir. Yes.
Okay.
Yes, sir.
So PVS is given here. PV you don't know for the this final condition. So you know like 5 times PT is PV plus PA. Now you know initially total pressure is 1.01, but later it increased to 5 times. So if total pressure become 5 times, then same way it will also distribute here. Hmm. So this would be this would be water vapor pressure, and this would be this. So can you solve now? Hint I have given here.
Trial,
Hello.
sir.
What would be the PV2? Can anyone tell? Finally here, what would be the PV2?
505.
Why? 505 is the like 5 times of PA and 5 times of PV. Both would be the 505, right?
Their addition will be 505. Sorry, sir.
So what would be the 5 times of PV? PV you already know, right? PV is this. Here only you are committing mistake. So PV you know, 5 times of this would be the PV2. Is it clear or not?
Once repeat, sir.
So actually this is the total pressure, okay? The moist air is compressed to 5.05 bar. So what is the total pressure? PT is PV plus PA. Now it is the initial one, and now later it is compressed 5 times. Total pressure is compressed 5 times, means this also become 5 times and this will also become 5 times. Okay. So 5 times
Yes,
of
sir.
PV and 5 times of PA. And for the relative humidity, you require the final vapor pressure only, na? So vapor pressure is 5 times of PV. And what is PV? PV is 3.69, na, initially.
Yes, sir. Understood.
So here 5 times of 3.69. And what would be the PVS? PVS would be because here they have given dry bulb temperature finally is the 150, and for that saturation temperature is given 4 point. It is in kilopascal, so that also you have to convert into 475.8. That also convert to kilopascal. Whatever will come, that would be our answer. In percentage, how much is it coming?
Sir, approximately 3.9.
3.9%. So this would be our relative humidity. So this type of question, if will come, then if you haven't solved these type of problems, then you would be stuck. So pressure will distribute in the gases in same proportion. Okay, is it clear?
Yes.
Okay, so I think for today it is enough. So in next class we'll finish the theory of this psychrometry completely, and we'll do problems, and in the last class we'll solve only conventional problems on the psychrometry. So if you would be from here till end, if you would be here now, then you will see, okay, most of the problems you will able to do, like nothing will come new.
Okay, sir.
So I will tell most of the things. Okay, fine, then we'll see in the next class.
Thank you, sir. Okay, sir. Thank you. Many thanks.
Okay, thank you.
Thank you.
So can you tell us that where can we find the link of all